This video introduces and explains to you how to read the standard normal table in Appendix A in the book. So this is how the standard normal table in Appendix A in the book looks like. You will see there's a column, it's a Z column, stand for the Z-score. Then it's report the area between mean and Z is area B, or the middle columns. So if you look at the graph, you will see that area B is the area between mean and Z, so the shaded area here. And the reason why the area on the left and the area B on the right are the same is because the normal distribution is symmetric around the mean. Then the table reports to you the area beyond Z in the third columns. So the area beyond Z is the area on the left of the Z-score and on the right of the Z-score. And again, the area of the left tail and the area of the right tail are the same because the normal distribution is symmetric around the mean. And this column is similarly record the Z-scores, but also different values of Z-scores, of course. And area between mean and Z, middle columns, area beyond Z, the last columns. So if you look at the Appendix A in the table, you will see that they only report the positive Z-score and do not report the negative Z-score. So positive Z-score is all of the value that's on the right of the mean, or all of the value that's greater than the mean. And negative Z-score is all of the value on the left of the mean or less than the mean. So the middle one is the mean. And again, in the Appendix A in the table, the standard normal table, they only report the positive Z-score and do not report the negative Z-score. And the reason is because the standard normal distribution or any kind of normal distribution is symmetric around the mean. So once you know the area B on the right of the mean, that represent the area between mean and Z, for Z is greater than 0, then you would automatically know the area of a negative Z because of the area between mean and Z for all of the Z-score that is less than 0. So now let's have some interpretation. Let's say if an observation has a Z-score of 0.3, this means that this observation is 0.3 standard deviations above the mean. And that is how you interpret the Z-score of 0.3 or any type of Z-score that is positive. So now let's pause for a moment and think about how you want to label the Z-score is equal to 0.3 in the standard normal distribution. And I would like you to label the area beyond Z and then interpret the area beyond Z. And then I want you to label the area between mean and Z and interpret the area between mean and Z. And all of the Z value here is equal to 0.3. So take a moment and think about how you would like to answer this question. So this is how the area or how you label the z is equal to 0.3 on a standard normal distribution, the mean is in the middle. The mean is in the middle, and it represents 0 standard deviation away from the mean. So the mean is itself, right? So it's 0 standard deviation 0 away from the mean. And 0.3, a z-score of 0.3 is greater than 0. So this observation is greater than the mean, or on the right of the mean on the distribution. So therefore 0.3 would be on the right of the mean. Or the observation with 0.3 standard deviation above the mean would be to the right of the mean. And now, how do we label the area beyond z equal to 0.3? So the area is everything on the right of z equal to 0.3. And if you look at the standard normal distribution in the appendix A, you will find that the area beyond z is 0.3821. So this whole area that I shaded here is 0.3821. And in order to do that, you go to the appendix A in the table, look at where the z-score is equal to 0.3 is, and then look where the area beyond z is equal to. So now, how do we interpret the areas beyond z when z is equal to 0.3? One way to interpret is that this area represents the probability that one observation is at least 0.3 standard deviation above the mean, and this probability is equal to 0.3821 or 38.21% in this case. So now, how do you label the area between mean and z when z is equal to 0.3? So the area between mean and z is, again, the mean is in the middle, or 0 standard deviation away from the mean. And this is a 0.3 standard deviation away from the mean. The area between mean and z is a shaded area here. And if you look into the z table with z is equal to 0.3, look over the columns of the area between mean and z, you will find 0.1179. How do we interpret the area between mean and z when z is equal to 0.3? The probability that an observation falls between the mean and 0.3 standard deviation above the mean is 0.1179 or 11.79%. Similarly, how do we interpret when an observation has a z-score is equal to minus 0.3? This observation that has a z-score is equal to minus 0.3 means that this observation is 0.3 standard deviations below the mean. Let's take a moment, pause the video, and label to me where the z-score is equal to minus 0.3 is on the normal distribution. Label the area beyond z, interpret the area beyond z, label the area between mean and z, and interpret the area between mean and z. So how do I label the z-score is equal to minus 0.3 on the standard normal distribution. Again, mean is in the middle, or is equivalent to the point where it's 0 standard deviation away from the mean. And the observation with the z-score is equal to minus 0.3 is an observation that is on the left of the mean, or 0.3 standard deviation below the mean. Label the area beyond z-score is equal to minus 0.3. So the area beyond z of z-score is equal to 0.3 the area beyond z when z is equal to minus 0.3 is everything on the left of minus 0.3. And again, the appendix A in the table doesn't report any z's that less than 0. So in order to know what the area beyond z when z is minus 0.3, you look for the area beyond z for z is equal to positive 0.3. And the reason we can do that is because the normal distribution is symmetric around the mean. Okay, so after you look into the table of the appendix A with the z is equal to 0.3 and look at the area beyond z, you will see that the value is 0.3821. How do we interpret the area beyond z for z is equal to minus 0.3? It is a probability that one observation is at least 0.3 standard deviation below the mean, and this probability is 0.3821 or 38.21%. Similarly, you can label the area between mean and z when z is equal to minus 0.3. So you're going to look into the appendix table in appendix A for the standard normal distribution. Look where z is equal to 0.3 is, and look for the area between mean and z, and you will find that this value is equal to 0.1179. Interpret the area between mean and z when z is equal to minus 0.3. The probability that an observation falls between the mean and 0.3 standard deviation below the mean is 0.1179 or 11.79%.